adopted Hadoop fairly early on is not because we just thought, oh, this is kind of the latest and greatest, we need to go and have a Hadoop cluster. Instead, it was the data team was asking questions of the data that required Hadoop as a solution. Okay. A lot of people ask me, like, should I adopt Hadoop? Should I adopt? And I said, well, what question are you asking that requires you to have a distributed framework for batch processing? Right? And we had people you may know. And at first, we were doing people you may know based on SQL. And that is kind of a mess. Like a long time, just very, very difficult to maintain and deploy. Whereas with Hadoop, it's much easier to build algorithms that are distributed across our entire set of data. In that world of Hadoop, we have Project Voldemort, Kafka and Azkaban, and Sensei. These are some projects that we have open source that, again, we built because we didn't find a solution in the market that satisfied the requirements of what we needed in order to scale our data products. Voldemort essentially is where the data from Hadoop goes to be pulled from the live site. Hadoop is batch processing, it's slow, it's just like a giant beast, it's an elephant, but it does great stuff. Voldemort is where you push the insights out to. This is a distributed key value in-memory cache that then the website will pull data from. Right? So you see, you pull up your LinkedIn homepage, there's a lot of great data there. You know, obviously that stuff has been pre-computed, and we're pulling it out from Voldemort. Kafka is about logging data. It's a real-time messaging service that scales so that we can log all the data that we want, and the data from Kafka goes straight into Hadoop. Sensei is search indexing technology, and Azkaban is essentially a scheduler for Hadoop. It's kind of like Uzi if any of you use that. On the relational side, we have recently migrated from Oracle over to Teradata. We have some production databases that are still driven by Oracle, but for the most part, on my side, sort of on the business analytics ad hoc, whatnot side, then we really will be focusing on Teradata. We also have an Aster data cluster. Aster essentially is a relational database built on top of a MapReduce paradigm, just like Hadoop. And there are some situations in which Aster makes sense for analysis. I can talk a little bit more about those later on and just dump into it. Pig is an abstracted language that runs on top of Hadoop. If you really want to program in Hadoop, you need to know Java. For data scientists, we don't necessarily need to be writing Java code just to pull insights out of the data, so we'll write Pig. Python and R are great for manipulating data, doing modeling. This is our visualization technology. So if you look at the InMaps that I just showed you, those are really driven by Gephi. Gephi is awesome. Gephi is an open source network visualization project that I think you can install Mac and Linux. I'm not sure if there's actually the Mac and Windows you can install. Any network data, once you start thinking about network data, you realize there's network data everywhere, and Gephi is really fun to visualize it. We use Tableau and MicroStrategy for some of our kind of visualization reporting needs. And we've built an in-house solution for reporting as well. And then once you get into this world of like hardcore data mining and machine learning and thinking about how we can roll out products that are driven by algorithms, then you end up thinking very hard about, okay, what is truth? Right? I have a target variable that I want to model. Do I actually know what the truth is? In a lot of situations, you don't. So we use crowdsourced technologies like Mechanical Turk, SamaSource. SamaSource is where you know the people, it's just that there's a team in a developing country somewhere that you're working with to help you process